Every day, in ports, in mines, on ships, and factories, billions of pounds of weight are lifted, pulled, anchored, and secured. And behind almost all of it lies a simple, ancient invention, the steel chain. But these are not ordinary chains. Some of them can lift over 300 tons. Some secure oil rigs in raging oceans. Some pull 200-ton mining trucks. Some anchor massive cargo ships during violent storms. To build something with this much responsibility, the engineering must be perfect. Every link must survive extreme heat, crushing force, and constant stress. Today we go inside a mega chain factory, a place where fire, steel, robotics, and raw power combine to create the strongest links on Earth. Later in this film, you'll witness an industrial chain pushed to its breaking point, a destructive test so brutal it will reveal the true meaning of engineering strength. All industrial chains begin with one ingredient, steel. Inside a blast furnace, iron ore, coke, and limestone melt together at over 1,500 degrees Celsius. Oxygen is blown in, separating impurities. Alloying elements like manganese, chromium, nickel, and molybdenum are added, each one tuning the steel for strength, hardness, and durability. The molten metal is poured into continuous casting machines and emerges as red-hot billets, glowing bars of steel that will become the backbone of heavy-duty chains. Before anything moves forward, each billet is analyzed by spectrometer. Its chemical composition must be perfect. Too much carbon, the chain becomes brittle. Too little, it becomes soft and stretches under load. Only the best billets will continue the journey. The next step is transformation. Billets are reheated to more than 1,100 degrees Celsius, hot enough to glow white-yellow. They enter massive rolling mills, where giant steel rollers apply thousands of tons of pressure. In just seconds, the thick billet stretches, thins, and becomes a long steel rod. These rods vary from 10 millimeters to 80 millimeters in diameter, depending on the chain size. Robotic lasers scan every centimeter of rod, checking diameter, straightness, and temperature. Nothing is left to chance, because a chain is only as strong as the steel it comes from. Once cooled, the steel rods are cut into precise segments. Each segment will become one single link. An automated cutting machine slices them with tolerances under 0.5 millimeter. Too long, the link won't close properly. Too short, it won't meet strength requirements. The cut pieces travel down a conveyor toward induction heaters. Here, massive electric coils generate magnetic fields so powerful they heat steel from the inside out, reaching forging temperatures of up to 1,000 degrees Celsius in seconds. The steel glows orange, soft, moldable, ready to be shaped. This is the moment when steel comes alive. The heated segments drop into bending machines, hydraulic beasts capable of applying up to 150 tons of force. With one powerful motion, each glowing bar is bent into a C-shaped link. The ends must align perfectly, because the weld that closes this link must withstand thousands of pounds of force, sometimes millions. 8K cameras capture this moment in slow motion. Metal fibers stretch, compress, and flow like liquid as the steel curves inward. In just one shift, a single machine can bend thousands of links, every one identical to the last. The most critical moment in building a chain, the weld. The The open ends of each C-shaped link are pressed together inside a flash butt welding machine. A massive electric current surges through the steel, and instantly, sparks erupt, white, bright, and violent. The metal edges heat to over 1,500 degrees Celsius. They soften, melt, and fuse into one continuous loop. When the welder releases pressure, the link is no longer open. It is sealed forever. Robotic grinders remove the excess weld bead, creating a smooth, seamless finish. If done correctly, the welded area becomes stronger than the rest of the link. If done poorly, it becomes a ticking time bomb. To guarantee safety, every weld is scanned, measured, and recorded. Welding isn't the end. Not even close. The entire chain goes through a heat treatment line. It is reheated to over 900 degrees Celsius. Then plunged into quench tanks filled with oil or polymer mixtures. Steam erupts as the glowing red chain disappears beneath the surface. The sudden cooling hardens the outer steel while maintaining toughness inside. After quenching, the chains enter a tempering furnace heated between 400 and 600 degrees Celsius. This step relieves internal stress and prevents brittleness. Done correctly, heat treatment gives the chain its true superpower, the ability to handle massive loads without breaking. now comes the moment of truth. The chain is clamped between giant hydraulic arms. The machine begins to pull 5 tons, 10 tons, 50 tons, depending on the chain's rated strength. The metal stretches microscopically, and sensors track every change. A certified industrial chain must survive a load 2 to 3 times higher than anything it will ever face in real operation. If a link elongates too much, if a weld shows microscopic cracks, if the grain structure fails, the test ends immediately. The entire batch is rejected. But the chains that pass, they earn their place in the world's harshest environments. Even the strongest steel will rust, and rust is the enemy of safety, so industrial chains go through surface finishing. Shot blasting removes impurities. Hot dip galvanizing coats them in protective zinc. Electro-galvanizing creates a thin, shiny, corrosion-resistant layer. Marine chains receive thick epoxy or special polymer coatings. Every coating is measured for thickness, often between 50 and 100 microns. This isn't cosmetic. It's protection that determines whether a chain survives decades or fails within months. The final step is assembly. Links are connected into 10 meter, 20 meter, or 50 meter lengths. Each chain is tagged with SA, alloy type, batch number, load rating, manufacturer code, heat treatment certification. Laser engraving ensures traceability from factory to field. Quality inspectors use 3D scanning tools to measure dimensions with micron-level accuracy. Only after passing all checks, best mechanical, chemical, dimensional, coding, is the chain released for heavy-duty industrial use. From red-hot metal to precisely forged links. From violent weld flashes to crushing proof tests, industrial chains are built with one goal: to never fail. They hold ships in storms, lift skyscraper beams, pull massive mining equipment, and carry the weight of industries around the world. Forged in fire, tempered by force, tested to survive, this is how the world's strongest chains are made. inside a heavy-duty steel chain factory.